line is parallel to one side of the triangle and intersects the other two sides, then it divides the sides so that they are proportional to each other. This doesn't say that it has to hit the midpoint, girls. It simply says, given that these two sides are parallel, then RT and TQ, so we're staying on one side of the triangle, and we're talking about the sides, not the bases, is going to be proportional to RU over US. Does that make sense? All right. So the converse says, so you're going to want to have these on separate little note cards. If the sides are proportional, if RT, so given RT over TQ is equal to RU over US, then what we can say is that TU is parallel to QS. Does that make sense? So one says they're parallel, therefore my side lengths are proportional to each other. The other one says my side lengths are proportional to each other, therefore my lines or my segments are parallel to each other. Okay? All right. So here when I say find x and ask you what theorem are you using, am I using the proportionality theorem or its converse? I'm using the theorem. And why do we know that we're using the theorem? Because I'm showing you that they're parallel, correct? I'm showing you that they are parallel. So then I would say that 44 is to what? Nope. Nope. Is to 35. We're staying on the same side and we're doing part over part. Okay? Look, up here it says RT is to TQ. Sides, one segment over the other segment. Okay? And that's going to equal then what? X over 36. So 35x equals, what's 44 times 36? Okay, and divide that by 35, and what is x? Does it come out evenly? So we're going to say approximately. Okay, it's an approximate. Well, why don't we do 35? Let's not do this. Let's do it exact. So that's going to be 1584 over 35. And does that reduce down at all? Does that simplify into a smaller fraction? That's it? And then we'll leave it like that. Because we want it exact. We don't want it rounded. Okay. Can we say that the segments are parallel? How are we going to prove it? So what am I going to do? We're going to be using the converse. So we're going to say 90 over equals over 40. But this is a question mark. So this reduces down to 9/5, right? And what does 72 over 40 reduce down to? 9/5 also. So the answer is yes, because we're dividing both of these by 8, correct? We're reducing the fractions. And so we get 9/5 is equal to 9/5, so they have the same proportion. Therefore, we can say that BD is parallel to AC. Mm-hmm.
We're using the triangle proportionality converse.
Mm-hmm. Okay, so we have 3 lines that are cut by 2 transversals. 3 lines that are parallel. Do you see that? They're parallel, and our transversals are these lines that are kind of coming down. They divide the transversals proportionally. So given that these 3 are parallel, then we can say that FK over KL is going to equal, what are we going to say? MN this is a form of the triangle proportionality, because if we were to extend these out, wouldn't we have a triangle? Wouldn't you see that we have triangles going on in there? Okay, Athena? Because we have 3 pairs of parallel lines, not just 2. Why don't we just call 3 parallel line theorem? I'm going to want you more to use it, and there'll be a problem in the homework where you're going to want to look at this and use it. Okay. You can put this one also in your note cards, please. You could even just start with the drawing on one side, and then what does it mean on the other side? Okay, so, and there's another one. If a ray bisects an angle in the triangle, then it divides the segment into lengths that are proportional to the other 2 sides. So if a ray divides or bisects an angle in the triangle, so that means we know that those 2 angles are congruent because it's bisected. Okay. Then it divides the segment. The segment is going to be this one and this one into lengths that are proportional to the other 2 sides. So I don't really want to say that they are congruent, but they are going to be proportional. So we could say that GR over RI is going to equal, what would I say? HG over HI, right. So this to this will be proportional to, starting with the same side of this triangle, this side to this side. Does that make sense? So knowing that we have an angle bisector of a triangle, we can create proportions with the bases and the sides. Okay? So, knowing that we have an angle bisector PR, we agree we have an angle bisector? Okay. We can say what? This looks like I lost a letter here. We'll call it T. What does that theorem say? Let's do it with letters first, not with numbers. That's an R. Right. That's what that theorem says. That's our angle bisector theorem. So now let's put in some information that we know. Do I know what TR is? Do I have enough information to say what it could equal? Maybe not physically as a number, but as an expression. Sarah? Yep, 15 minus x. If the whole length is 15 and this part's x, isn't that part going to be 15 minus x? So 15 minus x over what? Is going to equal over? Correct. So cross multiplying means 13 times 15 minus x is equal to 7 times x. Athena? Oh, no. Wait, TP over, oh, no. I'm just talking about the sides, yeah. Because we're not talking about congruence. We're just trying to set up a proportion. Okay, so 13 times 15 is what? How much? 195 minus 13x equals 7x. So 195 is equal to 20x. And so what does x equal? 9 point who? Exactly. There we go. Okay. On this next one. All right. What kind of a triangle is that? I'm sorry? A right triangle. I want to find x Do I know that this is an angle bisector? How do you know? The 4 and 4 on both sides. Okay. So I can do this one of two ways, can't I? What's one way that I could do? Pythagorean theorem. Or I can solve using the theorem. So I would say that 4 over 4 is equal to 4 root 2 over x. What does that really have x to be without even doing much effort? 4 root 2, right? If 4 is over itself, then doesn't 4 root 2 have to be over itself too? So that you get 1 is equal to 1, basically? Okay. You can go physically cross multiply and divide, but that's a lot of effort. So if you can intuitively see that this reduces down to 1, so this side has to reduce down to 1, the only value that x can be is 4 square roots of 2. All right, here we go. 3 sets of parallel lines, what am I going to write? What's my proportion going to be able to solve for x? Gabby. And so 15x is equal to 16 times 18. $288. Thank you. And what does that equal? Okay. Is that it? What's the last what? You know what? Just draw the picture on the one side and explain what it is on the other side.